Okay, what we're going to look at now is how to evaluate definite integrals or find the area under the curve using those same 6 basic integration techniques that we've been using. Um, you integrate the same, it's just now you have a definite integral. So this is nice. I'm pretty sure there should be a g there. So let's look at the integral from 0 to 2 of x times the square root of 8 minus 2x squared dx. This one should be pretty basic. You just let u equal x minus, or 8 minus 2x squared, and du then will equal negative 4x. So I get negative 1/4 the square root of u du. And then I would get negative 1/4 times 2/3 times u to the 3/2, which if I do some algebra, I get negative 1/6 times 8 minus 2x squared from 0 to 2. And if you plug that in, that's 4, that's 8. I get 0 minus 8. So negative 1/6 times negative 8 would be 4/3. Okay. What if you want to find the area under the curve of 5 over the square root of 25 minus x squared on the interval from 0 to 4? Well, this would be the same thing. I mean, you can graph this, but it's basically just a definite integral from 0 to 4 of the function 5 over the square root of 25 minus x squared dx, because you're adding up all those little areas. This 5, I'd move this guy out front. So I get 5, the integral from 0 to 4 of 1 over the square root of 25 minus x squared. And hopefully, since we've been doing these for a couple days, you realize that that's not a u substitution. You can't let u equal what's inside the radical because there's no x in the numerator. So I would look at something else. I can't use a conjugate because it's a square root. And since it is a square root function, that kind of makes me think it's going to be an inverse trig function. And if I'm looking at my rules, it looks like it's an arc sine. So that means a would be 5 and u would be x. So if I just follow that rule for arc sine, the integral rule, I'd have 5 times the quantity of the arc sine of x over 5 from 0 to 4. So I get 5 times the arc sine of 4/5 minus the arc sine of 0. The arc sine of 0 is 0 because the sine at 0 equals 0. The arc sine of 4/5, what would that be? Well, whatever that number is, we could put right here and multiply it by 5, and we'll get our answer. I was trying to think if you draw a 4, 5, just put that in your calculator, that'll give you that value, or leave it like that. All right.